Okay, guys, today we're going to talk about congruent triangles, really congruent polygons, but congruent triangles is kind of what I'm naming it. I'm going to use corresponding sides and corresponding angles to show that triangles are congruent. We're going to use properties of congruent triangles and prove triangles are congruent by using the definition of congruence. Our key terms: corresponding angles, corresponding sides, congruent polygons. Right. All right, guys, you need to write down the next slide. Here we go. Geometric figures are congruent if they have the same size and shape. Ooh, interestingly, similar figures have the same what? No.
Angles.
No.
They're proportional. Shape.
But different.
Angle. Size.
Blue. Similar figures have the same
Size.
no shape, but different
Size.
Similar figures have the same shape but different size. Okay? Congruent figures have the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Two polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are in the same size and shape are congruent. So, make sure we got this written down. Hopefully you guys are finished with it. If not, you can come back to it later. Alright, let's make sure we get this. I want to make sure that we get the concept that we're talking about here. Properties of congruent polygons. Okay? In this particular figure, I want triangle ABC is congruent to triangle DEF. Alright? Let's go over these again. Angle A is corresponding to which of these three angles? D. One ring to one ring. It's that simple. Notice how we write it. A, B, C, D, E, F. Precision matters, right? It matters if it says ABC versus if it says CBA, okay? Be precise. Don't be sloppy when you write these things. Be exact. Bless you. Okay? Make sure we get this too, because I think this is where a lot of the confusion begins. If I said side AB, not angle AB, but side AB, was congruent to side ED, would I be correct or incorrect? Be incorrect because of the precision, right? AB goes from one wing to two wings. Over here, ED goes from 2 to 1. Okay? I know. It's the same measurement. It's going to be the same measurement, right? But precision matters. If I say A to B over here, I need to say D to E over there. Any questions on that? Cool. Right? I'll come back if you need it later. Naming a polygon, you write the vertices in consecutive order. That's what I just said. For example, you can name polygon PQRS as QRSP or SRQP, but not as PRQS. Here's the part that's really important. In a congruent statement, the order of the vertices indicates the corresponding parts. When you write a statement such as triangle ABC is congruent to triangle DEF, you are also stating which parts are congruent. That's why I want you to write down that part. Let's move on. So check it out, guys. In case some of you guys are still maybe unsure how this works, let's see if another strategy works, like this one. You don't have to write this down, just follow along with me here. Got a touch? I would.
Yes, it's got the page.
Given that triangle PQR is congruent to triangle STW, identify all the pairs of corresponding congruent parts. Corresponding congruent parts means all of the angles and all of the sides. Some people are still unsure how it works. Let's see if this works. Okay. He's right there. Kennedy, what is the first letter in the first triangle? P is the first one. Second one is Q. Third one is what?
R.
Kennedy, what is the first letter in the second triangle?
S.
And then T, and then, oh wait, W, right? Alright, so, guys, if you need to know order, here we go. Ones go with ones, twos go with twos, and threes go with threes. 1 and 1 are congruent, 2 and 2 are congruent, 3 and 3 are congruent. What if I added another letter? 4 and 4. Hey! That's called corresponding, right? They have to match up. The precision matters. What about to the sides? That's simple. 1 to 2 has to match up 1 to 2. 2 to 3 has to match up 2 to 3. 3 to 1 has to match up 3 to 1. Any questions about that? Good. Hopefully you don't need to write it down, because we're going to be doing it a few times today. Matter of fact, you're going to do it right now. Okay? Take 3 minutes and identify for me all the pairs of corresponding congruent parts between polygon LMNP and polygon EFGH. 3 minutes. Morris. L is going to be congruent to what? L is going to be congruent to angle E. M and F. N and G. P. Good. E. And H. What about the sides? So just give me, what is MN going to be congruent to? Ah, good deal. And so on and so forth, correct? What's another way I could have done this? I don't see anybody doing it. Oh, right here. What could I have done? Draw a picture, right, guys? Could have drawn 2 different polygons. How many sides are going to be on this polygon? 4. Does it say it's a rectangle? Is it okay if I draw a rectangle?
It has 4 sides.
As long as it's got 4 sides and it's congruent to the other one, you're good. Okay? What might a problem look like that we're going to look at today? Here we go. Given that ABC is congruent to DBC, find the value of X. Alright. Angle C in DBC is congruent to what angle in triangle ABC? C. Senor. Alright, so, guys, if C is a right angle in one triangle, it has to be a right angle in the other, correct? That's why, if I want to solve for X here, I take 2x minus 16 and set it equal to 90. This represents the degrees of a right angle, right? Say it a few more times. Everybody should know that by now. I hope so. Be surprised though. Teach geometry one day. We'll see. If you need to know how to solve 2x minus 16 equals 90, go talk to your algebra 1 teacher. Okay? Alright. Another problem might look like this. Find the measure of angle DBC. Yeah. And that's a little bit difficult, right? That's tough. Alright. Mr. Worthy. Angle A corresponds with what angle down here? D. And if A is 49.3, what is D? 49.3. So that's 49.3 as well, because they have to be congruent to each other, right? Yeah. That's right, man. Right triangles, the acute angles are what? Not just Alec, but anybody. Yeah, well, almost. What do we call the word?
Acute angles lesson.
What'd you say? Complimentary. How long does breakfast last?
I didn't eat anything.
It's 90 minutes, whether you eat it or not. Alright, so, up in here it is. Alright, check it out, guys. Hey, 180 degrees in every triangle. If I know I'm subtracting out 90, that means that the other two angles always have to have a sum of 90. If you want to know what I'd get right here, I'd get 40.7 for my answer. Okay? 40.7. Any questions on that?
Why is it 139?
Because they subtracted it out of 180. What they do is they add 90 and 49.3 to get 139.3, subtract that from 180. Which isn't, there's always going to be typically more than one correct way to solve, right? I want you guys to get used to subtracting out of 90 instead of 180. But you could always do the same thing every triangle problem. 180 minus your angle measurements. Okay? Will never go wrong. Height. Take 2 minutes. Set it up, solve it. Let's say we did this, like the way I asked you. I want to draw a triangle DEF so that it looks the exact same as ABC. Am I off to a good start so far? Yeah. Okay. Now comes the fun part. I got to match up my corresponding angles. So watch how easy this is. A is going to be corresponding with what angle? D. B is corresponding with what angle? Try again, Bo. Ask your mom. And C is corresponding with what angle? Ah, no, it can't be, right? Because it's not in the same order if F is up here. B can only correspond with E. Our order matters. Great point that he mistakenly made. Okay, our order matters. Here's why I do it this way. Well, what's the distance from E to F? What's that side line? 10. And what about ED? So now it makes life a lot easier for me, right? You'll see that? If I redraw the figures so that they look the exact same, it's not cheating. It should be cheating, but it's not cheating, okay? Now it's like child's play. Okay. Coincidentally, what? Let me stop right there. 2x minus 2 equals what? 6. Okay? Now, 2x minus 2 equals 6. Okay? Add 2 to both sides. Here, I'll do the easy algebra problems. 2x equals 8. Divide both sides by 2. X equals 4. Just for good measure, I'll show you. 2 times 4 minus 2 is 8 minus 2 is 6. Okay? Alright. 2x minus 2 is equal to 6. What is going to be the measurement of BC? What? Yeah, no! 10, right? Duh, because they're corresponding, okay? What's going to be the measure of angle E there, Baloo? Yeah, it's going to be 53. Hey, Baloo, what's going to be the measure of angles F and C? X. Already did it. Perfect. 37 degrees, right? Okay? I could use something called the Pythagorean theorem to find this side measurement if I wanted to. Y'all with me? Do not start on this work and start setting side lengths equal to angle measurements. Alright? That's why I have no hair. Okay? Maybe when my kids come along, which they're not going to be here anytime soon, but maybe I'll have a little hair for them. Okay? Please don't be the class that sends all the hair off the edge. Please, I beg of you, okay? And things like setting 2x minus 2 equal to 90 or 53 or any other angle measurement will cause me to lose my hair. It'll cause you guys to not pass the class, which means you'll get your get next year, and then eventually you will have hope at the end of the hallway. Alright, so. Alright. Don't write this one down. Just listen to me as I go through it. Because these are still a thing, they're still out there, and they still exist, and I didn't want you to think that we were totally done with them. given that angle YWX and angle YWZ are right angles, so I've got right angles here. I'm also given that YW bisects angle XYZ. A bisector cuts an angle into two congruent angles. That W is the midpoint of XZ. Remember, a midpoint means it's the middle, so it cuts a line segment into two congruent sides. And that XY is congruent to YZ. Okay? Prove that triangle XYW is congruent to triangle ZYW. There's a reflexive property involved. There's going to be a third angle theorem involved. I didn't want you to think that we were completely done. We're not done with proofs. I'm just feeding them to you in doses, okay? My proof would start off with a given, talking about right angles. I would talk about the fact that all right angles are congruent to each other through what we call a right angle congruency theorem. I'd use another given proof or given step to talk about how YW serves as a bisector, meaning, gives me to my next step, that the angles that are being bisected are congruent to each other. Rather, the products of the angles being bisected are congruent to each other. Get another given statement. Scarborough, are you getting all this? To tell me that the two segments that are a result of the midpoint are congruent to each other. Talked about reflexive property. Talked about third angle theorem. Talked about a last given statement. If all of the angles are congruent, all the sides are congruent, the two triangles are congruent to each other. Okay? Today's classwork, you're going to have one proof. I want you to do your best to figure it out on your own. We will go over it at the end of class. Okay? Mr. Ballou.
I thought the given